Does the popular notion of infinite parallel realities have any traction, legitimacy in the theoretical math of physics communities? Or is it just wild sci-fi extrapolation on some subatomic level quantum uncertainty principles? It's an interpretation. Is being true or false isn't important. It's a way to talk about the abstract math more concretely. It isn't testable, only testable theories are relevant at all. The sci-fi interpretation of such parallel realities is also silly. If they did exist, the overwhelming supermajority of them anywhere close to our reality would be essentially identical to ours. Many worlds is an interpretation of quantum mechanics that solves the measurement problem by postulating that the wave function simply never collapses. Instead, what we observe as collapse is really our own consciousness becoming entangled with the quantum system. To use the classical Schrödinger's cat thought experiment. In the classical Copenhagen interpretation, the cat is in a superposition of being both alive and dead until the box is opened and the cat is observed, at which point the wave function collapses to either an alive cat or a dead cat. At this point of observation, the cat is either definitely alive or definitely dead. In the many worlds interpretation, we begin again with the cat in superposition of being both alive and dead. But when we open the box, instead of collapsing the wave function, instead our own wave function becomes entangled with that of the cat's. Now we are in a superposition of observing a living cat and observing a dead cat. Every possible outcome permitted by quantum mechanics is real and actually happens in parallel, whence the name many worlds. Unlike in sci-fi stories though, there is no way to travel or communicate between these parallel worlds. Once they have diverged, their wave functions can no longer interact. For a start, the popular view is in fact unrelated to what is considered many-world in QM. The pop version is just the idea that the what-if scenarios for different set of events all exists in parallel to the reality we know. Typically, SCI-Fi settings will justify this by appealing to the quantum interpretation of the many worlds. But even if we were to assume the many-world interpretations indeed creates parallel universes, which, as others have said better than I could, is a wild extrapolation of the interpretation, it wouldn't create the alternate histories we see in fiction. The only difference between universe A and B would be that in one, the superposition of a quantum system collapse one way in one universe, and in another in the other universe. So it would be an infinity of basically identical universes. The only way I know of in which we could have the infinite parallel histories we see in fiction would be if the universe is actually infinite. In such a case, there would statistically be places where matter and energy distributed in the exact same way that led to us. And statistically some with various differences. If you're really interested, check out the audiobook, The Hidden Reality, by Brian Greene, a well-respected theoretical physicist and science communicator. Each chapter takes you through all the possible theoretically plausible versions of parallel universes, e.g. eternal inflation, string theory landscape, many worlds of QM, etc. There is no woo or any claims one way or the other. He just describes in precise terms how multiple worlds could exist within the context of each concept. And he's just awesome to listen to. The starting point for theoretical physics is observation of reality, and attempting to use mathematical models and abstractions to explain the observation, in contrast with experimental physics, which is essentially trial and error. For there to be any form of legitimacy, there first has to be a documentable observation. We don't have this part yet.
Don't forget to like and subscribe so you don't miss our next exciting video.